Hi all, today we are taking notes on day 9, which is section 5.3, solve by factoring. Today we're just going to do a factoring review, and then tomorrow you will actually solve by factoring. So, just a factoring review before we get started with our examples. We've done 4 main types of factoring. We've done the greatest common factor, which is that first example there. We've done the difference of two squares. We've factored product sum trinomials and product sum split the middle. So we're going to do examples like all 4 of those today, and then you're going to do a few on your own. You should be taking notes along with me. And just a reminder, all of our factoring will be done without the use of a calculator. So all the notes that we're taking today, you should not be using a calculator. As a quick reminder, this would be something to write down. You should always look for the greatest common factor first. So always see if there's anything that you can take out of every term. It's going to make your life a lot easier in the long run. Okay, so we're going to move on to 2 examples. As I just said, always look for the greatest common factor first. Greatest common factor of 16 and 8 is 8. 8 is the largest number that divides evenly into both of those. And then we have x squared and x. Their greatest common factor is x. Now, 16 divided by 8 is 2. X squared divided by x is x. Bring down your addition sign. 8x divided by 8x is 1. A lot of students forget that 1, but that 1x is a very important placeholder. Now this is not factorable anymore. It's not a difference of squares, it's not a product sum trinomial, so we are finished with our factoring. In order to check our answer, we can distribute that 8x again, so I'm going to do that over here to the right. 8x multiplied by 2x is 16x squared. 8x multiplied by 1 is positive 8x. Now this is what we started with, so we know that we factored correctly. Looking at the second example, the greatest common factor of 18 and 32 is 2. We have a squared y to the 4th. Those are not the same variables, so we can't factor anything else out. After we factor out a 2, we're left with 9a squared, subtract 16y to the 4th. Unlike the first example, we don't stop here, we need to keep factoring. This binomial is a difference of perfect squares. Remember that this will factor into 2 binomials. 9a squared is 3a multiplied by 3a. Remember with that with the difference of squares, you're going to have 1 negative, 1 positive. Those can be in the opposite order if you would like. 16y to the 4th is 4y squared and 4y squared. Don't forget about that 2 that we factored out. That needs to come out in front. This is our final answer. So that was 2 examples that involved the greatest common factor, and then the second one was the difference of perfect squares. Moving on, here's our next example. First thing you want to do is factor out the greatest common factor. Greatest common factor of 3, negative 24, and 21 is 3. That last term does not have an x, so we cannot factor out an x. We're now left with x squared, subtract 8x, add 7. This is a product sum trinomial. You're looking for 2 numbers whose product is positive 7 and whose sum is negative 8. So 2 numbers that multiply to positive 7, add to be negative 8. I'll let you think about what those numbers are. We have x and x. 2 numbers that multiply to positive 7 and add to be negative 8 are negative 7 and negative 1. Don't forget about that 3 that we factored out, and that comes out in front. This is our final factored form. Moving on to our next example. Here's the next one. This is a split the middle or guess and check example. I'm going to show you how to do it both ways. So we're going to start by looking for the greatest common factor. Out of negative 2, 21, and negative 27, there is no greatest common factor. So we can't factor anything out. Now we're going to start with the split the middle. First thing you want to do is multiply your a and your c. So negative 2 multiplied by negative 27 is positive 54. And remember that you should be doing this without a calculator. Now I'm looking for two numbers whose product is positive 54 and whose sum is 21. So two numbers that multiply to 54 and add to be 21. Those two numbers are positive 18 and positive 3. So remember, this is called split the middle because we want to rewrite this middle term in terms of 18 and 3. So our first term stays the same, negative 2x squared. 21x becomes 18x, add 3x, and then the negative 27 stays the same. So this is the exact same as our first expression, except we split that middle term into 18x, add 3x. Now you want to put a line down the middle, and you want to factor the left side and factor the right side. So out of the left side, I'm going to factor out a negative 2x. I'm left with x, I'm left with x subtract 9, because positive 18 divided by negative 2 is negative 9. On the right side, I want to factor out a 3, and I'm left with x subtract 9. At this point, I want to check, am I on the right track? These two sets of parentheses should match. Because they do, I know I'm on the right track. Last step. Our final factored form becomes negative 2x, add 3. That's because those are what are out in front. And then x subtract 9. So that's the final factored form. That's the split the middle method. Now I'm going to do it with the guess and check method over here on the right. Just rewriting the problem. Okay, the guess and check method is the one that uses the x. So here and here are the two terms that multiply to be negative 2x squared. That's going to be negative 2x and positive x. Over here on the right are the two numbers that multiply to be negative 27. I'm just going to make a list of factors. Our options are negative 1 and positive 27, positive 1 and negative 27, negative 9 and positive 3, or positive 9 and negative 3. I'm going to try this bottom one here first. So I'm going to put my 9 here and my negative 3 here. Now what I want to do is multiply across. Negative 2x multiplied by 9 is positive 18x. Negative 18x, sorry. X multiplied by negative 3 is negative 3x. Add those and I get negative 21x. I really want a positive 21x. So those are not the correct answers. Negative 21 is close to positive 21, but it's the wrong sign. So I'm going to erase these so they don't confuse us. So an idea might be to make this a negative and this one a positive. Multiplying across again, negative 2x multiplied by negative 9 is positive 18x. X multiplied by a positive 3 is positive 3x. Adding those up, I get 21x. That's what I want from my middle term here, so I guessed correctly. Last step is to write out our final factored form. You want to follow those diagonals, which gives me negative 2x, add 3, and then x subtract 9. And if we look at our answer to the left, our two answers match. So you may use the split the middle or the guess and check method, whichever one you are more comfortable with. Now we have one more example together, and then you guys have a few on your own. Okay, last example. This is factor by grouping. This is similar to the split the middle method. We're already split. So you want to put a line down the middle. Look for the greatest common factor on the left side. There is no greatest common factor to 7 and 6, but I can take out an x. When I do, I'm left with 7x add 6y squared. Looking at the right side, my greatest common factor is 2, and then both terms have a y. When I do that, I end up with 7x add 6y squared. At this point, we can check. Our two sets of parentheses match, so we know that we're on the right track. Final factored form becomes x, add 2y, and then 7x, add 6y squared. This is our final answer. Okay, so those were all the different types of factoring that you could see. Here are 4 examples for you to try on your own. At this point, pause the video, take 2 or 3 minutes, complete the examples, and come back, and I will show you how to finish factoring. Okay, welcome back. We're going to do these together. Hopefully you've tried them. Out of 35 and negative 15, the greatest common factor is 5. Both terms have an x, y. When I factor that out, I am left with 7x subtract 3. Can't factor that 7x subtract 3 anymore, so this is my final answer. Looking at the second example to the right, there is no greatest common factor. This is just a product sum trinomial. 2 numbers that multiply to negative 21 and add to be negative 4 end up being negative 7 and positive 3. If you had it written the other way, x add 3 and x subtract 7, that is also correct. But what's important is it needs to be negative 7 and positive 3, which add to be negative 4. So both of these are correct answers. Okay, this next example is a difference of perfect squares. There's no greatest common factor. 9 multiplied by 9 is 81. Then have x and x. 1 subtraction, 1 addition. Y to the 6th is y to the 3rd multiplied by y to the 3rd. We can't factor either of those anymore, so this is the final answer. Last example is split the middle. I'm going to do split the middle. If you did guess and check, that's fine. 6 multiplied by negative 4 is negative 24. 2 numbers that multiply to negative 24 and add to be negative 5 are negative 8 and positive 3. So rewriting, I have 6y squared, subtract 8y, add 3y, subtract 4. Putting a line down the middle. Out of the left side, I can factor a 2y. I'm left with 3y subtract 4. Out of the right side, the only greatest common factor I have is 1. So I'm going to write that 1 out in front just so I remember it. And I'm left with 3y subtract 4. Now, my parentheses match, so I'm on the right track. Last step, the final factored form becomes 2y add 1 and 3y subtract 4.